Hey guys, this is Karan here. I live in Saudi Arabia studying 10th grade in Yambo International School. Today what we'll do is talk about log functions. But before we start, what I'm going to do is teach you guys the basic rules in calculators like this where you cannot change the base. Okay, this is cashier calculator, and in this calculator you cannot change the base. I haven't used this calculator at all, so it's still brand new right now, even after 3 months. But this just for the demonstration, this calculator which looks like this, cannot change its base. Okay, though it has log function itself. So what I'm going to do is, since the calculator is only logarithmic with the base of 10, log of the base e containing within the calculator, might wonder how in the world are we going to figure out this problem, such as this one. So if you have a problem like this, log 8 and 9, how in the world are you going to solve this problem in the basic calculator? Well, how you actually do this is by the change of base. Okay, this is known to be change of base. Okay, now what happens is that you have 8 as the base. Okay, whoops, the question wrong over here. 3 as the base and 9 as the exponent of 3, right? So it would be 9. Since 9 is the exponent, you write 9 at the top. Since 3 is the base, you write 3 at the top. Okay, now you can also write this as natural log of 9 over natural log of 3. But you cannot write like this, because many students, including my friends, make mistakes like this. They just write log 9 over 3. Well, it's not the same thing. It's not the same thing because this contains the base 10, base E. So you gotta have the same bases. This does not have same bases. This implies that log of 10 is raised to 9 over 3. Okay, which is not the same thing, so this is wrong. Okay, you can either write it like this or like this, and you can basically, what you can do is put this in your calculator. Because now it has log base of 10, you can divide log 9 by log 3 and you can find out the actual answer of this. So what we're going to do is now try to solve this examples in such as this, okay, such as including of base, and we'll slowly move on to harder examples. So let's go ahead and talk about log 2 5. We can also write it like this, like log 5 over log 2, or some people might want to write it like this, natural log of 5 over natural log of 2. But at the end of the day, both will come out to be the same value, which is 2.32. Okay, so you see, I did this in my calculator and it gave me the answer. So you can actually solve this hard example, which does not have the base of 10, by using this calculator right here. Okay, all you have to do is just change the base, and we may realize at this point that a lot of property has some similar ideas, right? Such as, if you see, I mentioned this in my last video. In my last video I mentioned this as a lot of properties, such as any number such as a raised to the 0th power has 1, right? We learned this a long time ago in middle school. So now if you contain log of the same base raised to the 1st power, it would equal to 0. So you see, it's how they are related to each other, and we can all conclude. And we can understand these things over here. Okay? We're also going to talk about the properties here. So since I was talking about the properties, let's go ahead and talk about the properties that we'll see. We talked about change of base, now we'll talk about the properties. The properties are like this. We learned in exponential form that if x raised to a power multiplied by x raised to the b power is equal to x raised to a plus b, right? This is the first one and you need to remember this. Now a is the exponent. If x raised to a divided by x raised to b basically means that x raised to a minus b. The third one, x raised to a whole raised to b, basically means that x raised to ab. Okay? Now this over here, we can also apply this to logarithmic functions that we can. Yes, we can. Okay? So the first that comes up, let's see if I can fit this, is product property. Product property basically says log of phi x, which can be, how can we make this into this form? Well, product property tells us that the given form is this, which is this over here, okay? We can split this apart as log phi plus log of x. So we can conclude that since they're adding, okay, they can multiply each other. That's the product property of logarithm, okay? You might compare to this one, okay, but it's not similar because you see you're adding in the logarithms and it's the total. You can do this as multiplications as well. The second one is quotient. Just gonna write Q over here, which basically means the log of x over 3 basically means that log of x minus log of 3. Okay? And we can all conclude this one with exponential form, because as you guys can see, it's subtracting when they're dividing. It's subtracting when they're dividing. It's when you add it, it's a product. When you add it, it's a product. It's basically the same thing. Nothing hard. It all relates to itself. Now the third is power property. Power property. Power property basically says that if you have log x raised to the 5th power, basically we turn out to be phi log x. Now I mentioned this in my previous video that wait, hold on a second. I mentioned, if you guys can see, nope, you can't. So I mentioned in my previous video that we had a problem like this. We had a problem like log phi to the 3rd power is equal to n. If you guys recall, we had a problem like this, and what I told you to plug in 3 over here. That's basically the same thing. Plug in phi over at the start, which basically come out here, and that's the power property of logarithm. And that's basically it. Okay? Now let me go ahead and explain why this is the case. The first one, starting with the first one. Let me go ahead and explain each and everything in detail so it gets easier for you guys to understand, okay? And again, I try to make this stuff as easy as possible. Okay, so let me go ahead and erase this. Now product property is what we are going to talk about. The first, let me go ahead and explain. It's because if let a is equal to log phi, b is equal to log of x. Okay, so 10 raised to a would be 10 raised to b would be x, and this would be phi. You all agree with it, right? So since the bases are 10 raised to a, which is 10 raised to the log phi, would give us a, and 10 raised to the b would give us x over here. Okay? This is how it works. So here I've explained this. Second one would be log phi x is equal to log 10 raised to a times 10 raised to b. Okay, you see where we are going? This is the first step right here. Second step is coming across. So it would be log 10a plus b. Okay? Which basically is, since the basis is 10, this would cancel out as 1. So this would basically become a plus b, which is, replace the values with a and b, which is log 5 plus log of x. You see where I went through, right? Easy and clarified. Now let's use the properties of logarithm and expand a few of them. Now the property I told you is the first one only, because at first when I started learning it, first one seemed confusing because I couldn't compare it to the exponential function. So I mess around with that problem and try to find out an easiest way to explain you guys the properties of the first product property of logarithm. Okay, and let's go ahead and solve with over next. Take few examples right now. So now you'll take few examples and try to involve those property in those examples that you're using. Okay, so the first one is what if you have log base 2 x over 17? Well, that would basically mean that log 2 over x minus log 2 of 17. Easy as that. Nothing hard. Second, what if you have log 2 radical 18? Now we need to know, we can't really write radical 18 in the logarithmic form, so we might need to convert it into an exponent. So how would you do that? Well, it's nothing hard. All you have to do is, it's 8, radical 8. All you have to do is that make it into an exponential form. That would be this. That would become 2, 8 right here. This would become 2 cubed over here. So yep, that's 8. Okay, sorry, that was a typo in my writing. Whoops. Okay, so if you have radical 8 over here, and you would basically do log of 2, 8 to the half power, right? That would give you the radical 8. Then you move on over here, half. Basically, you put down this value over here, so you have half log of 2 raised to the 8th power, right? And you can simplify the 8. 8 is equal to 2 cubed. We all should know this. So this would, let me just go ahead and come up across here. So it would be half log 2 raised to the 3rd power, right? Now we can do this by coming 3 here, multiplying 3's. That would be 3 over 2 log 2 over 2. And we all know that 2 over 2, same exponent, cuts it out. Answer is 3 over 2. Okay, easy enough. Now since I've jumbled every single concept, I want to make you guys clear. So we start off with this problem over here, which says log of 2 over radical 8. Radical 8. So we rewrite this into an exponential function, okay? That would be 8 raised to 1/2. That would give us radical 8. Now we notice that 8 could also, we notice the property that we can also rewrite 1/2 in the front of this. So we do that over here. Now we notice the exponent 8. There is an exponent 8 which comes out to be this. So we write this form, and after doing that form, we can multiply 3 times 1, that gives us 3/2, and we notice that the base and the exponent is alike, so we cancel them out because they are equal to 1. So 3 over 2 times 1 is equal to 3 over 2. That's the reason why we get 3 over 2 as our answer. Let's go ahead and solve another problem involving natural log, because this involved logarithm. Now it's going to involve natural log. third one is natural log of 3x squared over y. Nothing hard, it would be natural log of 3x squared minus natural log of y. Now it's not done yet because now there's 3x squared which you can break apart into 3 plus natural log of x squared minus natural log of y. Okay, you can add parentheses as well if you want to, but that's just something extra. Now 2 is what we can rewrite this as like this: natural log of 3 plus 2 natural log of x minus natural log of y. Nothing really hard. It's just the properties that we use. Here we find a new property. Okay, so bingo here. Then we find property from here. So that's the reason why we subtracted. So basically we find 2 properties involving this stuff. That's basically it. Let's go ahead and solve the 4th example. I hope I'm making this clear to you guys. Fourth one is natural log y multiplied by y minus 1 squared. Now this would be a little difficult because we haven't talked about this at all, but remember, we should recall our properties that we talked about. Okay, so we should always recall the properties that we talked about. So let's go ahead and do that. Natural log, natural log of y plus natural log of y minus 1 squared. Now we all know 2 should come over here. Yep, that's it. If you're on the right track, you got it. Okay, and if you think we can still divide this, 2 natural log of y minus that, we cannot, because it's already in the form that it's in the bracket form, so we can't really do that. Okay, now let's go on different directions. This is it for this properties, because we already dig it out a lot of problems involving the hard ones as well. We mostly solved the hard ones. There was one medium example and one easiest example in this 4 problems. Now let's go in different direction. That is, before in this problems we are going to talk about rather condensed version of expression, and we'll be expanding them. Now let's go on the opposite side, that is to take the expanded version and contrast them. Okay, so we went on the contrast version and expanded them. Now we'll take this version and go to this version. Okay, it's simple as that. Nothing really big deal about it. It's just that we went to the right now. We're going to take a turn, U-turn, and go to the left. Okay, so first example for this left turn would be log of 4 minus log of x. Well, that's basically log 4 over x. That's it. Okay, nothing really hard. Now I'm starting off with the easiest example so you get used to all the properties. Second example. The second example that we will talk about, okay, is 2 natural log 8 plus 5 natural log of z. Well, this is basically the exponent that we came up. 2 plus natural log of 2 is the 5th power. Then we add this. That would basically mean 8 squared. Okay, this is z. Okay, that would be 8 squared would be 6. 64, then z, then phi. Z. That's basically it. Now if you're having diffusion in seeing this problem, it's basically the camera is kind of getting distilled for some reason. Okay, but I'm trying my best. The third example that we talk about is 4 natural log 3 minus 2 natural log x minus natural log y. Ooh, that's a lot, right? Do this, natural log of x squared, natural log of y. That was easy. Okay, then we can simplify this over here would be natural log of 81 minus bracket. Let's do this first. Plus natural log of y. So since doing this we would make it, since it's minus we have to make it plus because we're multiplying this, right? So we make this plus. Doing that we add that and we get 81 minus natural log of x squared y would be natural log of 81 divided by x squared y. That's it. Okay, now let's go ahead and consider the last example of this section before we actually end this video. Is that the fourth example? 2 natural log of 3 minus half natural log of x squared plus 1. Okay, so it would be natural log of 3 squared minus, can write half, so it would be natural log of x squared plus 1 is the half exponent. Okay, that would basically mean they're in square root. Okay, if it's square root you don't really write 2, but it's actually 2 there. Okay, so it's half right there. I know that for sure. And 3 squared is 9, so 9 minus natural root log, of x squared plus 1. That would basically mean natural log of 9 over square root of x squared plus 1. That's bingo, we got it. Okay, so that's it for this section. And now what I want you guys to do is that there's a Facebook page link down in the description. Please go ahead and like that Facebook page. It really helps me a lot. If you enjoyed this video, if it really helped you out, like, comment and subscribe. It really helps me out again. And share your videos with your friends and family. Thank you for watching. Peace out, guys.